So, welcome back to this quantitative finance program. So, I am sure you have till the last class we discussed Black-Scholes model, the Ito's lemma, the Wiener process, and based on the assumptions, different assumptions, we were able to understand though briefly the concept of Black-Scholes model and what were the assumptions of Black-Scholes model. The concept of there is no brokerage cost, risk-free interest rate, lending borrowing is fixed, then volatility concept and all these things we did go into details. And before that, obviously we have considered different type of options, how options can be combined, the straddle, the butterfly, the bear spread, the bull spread, so on and so forth. And in the initial part, if you remember, after going through the different averaging techniques, before that we did consider the concept of portfolio management and how safety first principle, Markowitz model and all these things could be considered, or the ratios rank the assets in the portfolio considering the excess return with respect to beta, excess return with respect to standard deviation, all these different models were considered. Now, for today and the next day, the class would be not any concept wide discussion, it will be we will just deviate from our concept of how we have been tackling the course. Here I will give you more of a very specific technique which is used in portfolio optimization, advanced set of techniques which is known as robust optimization. There is another concept of reliability optimization also, there is concept of stochastic programming also. So, the problems which we will discuss are the actual problems which we have solved, and based on that it will be much easier for me to explain the nuances of the optimization, what are the concepts we consider, so on and so forth. So, rather than trying to understand the nitty-gritties, I am sure it will give you a much better flavor that what are the changes in the model which occur the moment we consider non-deterministic nature of few of the parameters which are considered in the optimization. But before we start discussing the models, we will discuss some models. Before that, we will discuss what are the parameters, what are the variables which are considered. Before that, I will discuss a very important concept which is used in statistics and optimization in the bootstrapping method. Now, as the name implies, bootstrapping means if somebody is wearing a very high till the knee length boot and you have to tie the laces. So, you basically start tying the laces from the bottommost level, tighten up each and every lace which is there in the eye of the shoe, and then basically continue doing it till you reach the highest level and you tie the lace. So, bootstrapping exactly like this, that we keep repeating some set of simulation, some set of mathematical procedures till we are able to understand the general characteristics of the distribution based on which we are trying to do the study. So, it basically gives you some resampling technique. Sampling means you pick up some set of observation from a population, and resampling means you keep repeating, picking up sample from the population and doing it in such a way that the characteristics of the samples and the resample and the average of the samples in the long run gives you some information about what are the parameters of the population, and they do give us to a high level of accuracy what are the parameters of the population. So, what is the background of bootstrap? Let me consider it in very simple words. Let us consider we have a sample of n observation. Now, this small n which we are considering, so the small n which we considered is not the whole population. Say for example, if we have all the number of students who have taken the CAT examination, the common admission test examination for the MBA program, or say for example, the GATE examination, graduate aptitude test related to MTech and PhD program in India, or say for example, somebody is interested in taking the GRE examination or the GMAT examination or the JEE examinations, either the main or the advanced, whatever you consider. All number of students who take we consider as a population, and that population in the practical sense or the theoretical sense we will consider is to be infinite. So, whatever characteristics we get, the mean, standard deviation, mode, variance, skewness, kurtosis, all these things are values which we are interested to find out, because that will give us some information of what the distribution is. Like in the normal case, if you note, we always write mean and the variance. So, these are the basic parameters of the normal distribution which we want to know, because that will give us a lot of information or all information about the normal distribution. Now, as we do not have the population, what we do? We have to pick some small n number of observations. So, this n is a small n on observation, which is a subset of the capital so called infinite population which we have. From consider this n number of observation has been picked up from any unknown observation. That means, we do not know what is the underlying distribution of the observation from where we are picking up, and consider that to be u. U is not uniform, is any arbitrary distribution. We call this as the original sample x. So, let us pick up n observations. So, we will basically have observations marked as x1 to xn, where x1 is the first observation we pick up, first set observation you pick up from the sample of n size, x2 is the second observation you pick up, so on and so forth. Now, we want to know, as I mentioned, what is about the parameters for the example, the mean value, the median, the standard deviation, the upper quantile, the skewness, kurtosis of the original distribution, because till now we have picked up a sample of size n from an unknown distribution. Now, a bootstrap sample, what we need is a sample of size n which you have picked up, which is forming by randomly selecting some set of data with replacement or without replacement also it can be. Without replacement can only be done if the sample size is very huge. Can be done such that from the original population we want to pick up such that it will be denoted by x star. So, what we actually want to do is that consider the population is there, we pick up a small sample or a sample n, and we want to pick up observations technically from this n in such a way that by repeating the set of observation time and again, not the same set, like we pick up again, then note down the characteristics, again put it back, again pick up, note down the characteristics and put it back. So, we keep repeating in such a way that the x stars which you pick up at each and every go, in the long run the characteristics of the x stars will be in such a way that it will actually give you the characteristics of the population. Now, you may be asking that why we are not drawing all the information from x. The reason is that we do not have any other information apart from x which was of size n, because if we had, we would keep repeating the set of observation of small n size and which would be denoted by x, x is this one, such that whenever you keep picking up the sample, the characteristics of the sample in the long run would actually be the population, but we cannot do that because we have only one set of sample of n size. So, we resample from this x of size n such that the characteristics of this x star in the long run slowly mimics the properties of x, which in a way would definitely give you some or a lot of information of the actual population, and we want to basically have some study about the mean, standard deviation, variance and so on and so forth of the actual population. So, how we do that? I will give you a very simple pictorial and step by step concept how you do that. Consider the original sample which you have picked up is x and it is known as x1 to xn. Now, also consider that you are able to pick up such x number, capital N number of times. Now, your question would be, would those observations which you are picking up in the first small n number, would some or all of them would be repeated in the second set of observations we pick up? Answer is yes. It may be with repetition, it may not be with repetition, but some of the observations may be repeated. Now, once you repeat the sample of n times, generate a sample x star of size n from x by sampling with replacement. Now, note the word with replacement, reason is very simple. Say for example, you have a box of chit marked 1, 2, 3, 4 and consider theoretically that is the size of the population. So, if I ask you a question, or let me make it a little bit more explicit, consider there are 2 1s, 1 2, 1 3, 1 4. So, total number of such chits is 5. Now, if I ask you, if I pick up 1, what is the probability? I only pick up 1 chit at a time. So, the probability of getting 1 is 2 by 5, probability of getting 2 or 3 or 4 is 1 by 5. Now see what happens, consider you pick up 2 observations one after the other and you do it with replacement. So the probability of getting a 1 for the first observation will be 2 by 5, you note it down, keep it back in the box. So again the total number of size of the chits in the box is still 5. Again if you pick an observation, then the probability of getting a 1 still remains 2 by 5. Or else if you pick up the first observation as 2, note down the probability is 1 by 5, again replace it in the box, again pick up and consider 2 number also comes again. Hence the probability against remains as, or rather than using the word probability, let me use the word of relative frequency, it remains as 1 by 5. Now if you keep repeating for any set of observations with replacement, the corresponding probability remains the same. But consider that if you are doing without replacement, that means you pick up one observation, note it down, consider for the time being it is 1. So its probability would have been is 1 by 5, 2 by 5, note down 2 by 5 and keep that chit aside. So now if you think what are the number of chits which are left in the box, there are only 4 now, that is 1 1, 1 2, 1 3 and 1 4. So if you pick up observations any one of them in the second picking, now the corresponding probability of 1 getting is now not 2 by 5, it is now 1 by 4. Similarly, the probability of getting 2 which was actually with replacement coming out to be, say for example 1 by 5 is not 1 by 5 now, it is now 1 by 4. Or say for example consider that we are doing with replacement and the first chit we pick up is say for example 2, so the probability is 1 by 5. Second time if I ask you the question what is the probability of getting a 2, the 2 has already vanished because it has been kept aside, then the corresponding probability of 2 is now 0. Hence the concept of with replacement would be very important. Now if I ask you the question can we do it without replacement, the answer would be yes, if and only if the actual sample size and the number of observation is huge. Because in that case if one observation goes, then the corresponding ratio which we find out, that is the total number in the numerator, the total number of events or total number of favorable cases by divided by the total number of such pickings, that ratio would not change much. Because say for example if you find out the ratio of 1000 to 1001 and then you so consider this, what I was saying is this and this almost remain the same. So if you increase it too large, that means the observations of the pickings also increase very large, that means the numerator and denominator increase, then reducing one number from the numerator and denominator does not change the corresponding probability. So in order to basically overcome that, we will always consider with replacement. Now once you have done with replacement, what you have? So you have picked up n and small n and you basically repeat it capital N number of times. So what I am saying is that in the bootstrapping you note down the first characteristics of the first sample n, small n which you picked up, characteristics may be mean, median, mode, whatever you want to find out, note it down. Then you again replace that in the population, again you close your eyes and again pick up a chunk, then again remember the chunk is of size n. Again you note down the characteristics, say for example mean, median, mode, whatever you want to find out, note it down. Now you keep repeating it, say for example a huge number of times. Now the means, or say for example the means value which you have and each and every such pickings you are trying to find out, note them down in a separate column. Now if you had the mean, say for example for small size n, n is considered for the time being as 30 and you have found out the average of such 30 observations 200 number of times. So first picking you pick up is 30, note down the mean, keep it aside. Again with replacement, again pick up a size of 30, note down the mean, keep it aside. Again you pick up the third time, note down the mean, keep it aside. You such do replacements and picking up 200 number of times. So actually what you have, you would basically have such 200 averages where each an average is basically the average of such 30 observations. So technically if I ask you the question that what is the averages of these averages. This is actually the average of 30 into 200 such observations. Now 30 into 200 is very large number, which means that if I am able to increase this number, not n, if I am able to increase that number 200 to a large number, then the averages of whatever characteristics I want to find out in the long run will slowly come out to be the population average, and that comes out to be true depending on some characteristics of fulfillment which we have been able to do. So, we will follow this principle and basically try to enumerate in a very simple qualitative sense how this concept of bootstrapping can be done. Now, it says that get k number of bootstrapped samples. So, x which you have picked up initially from that actual in the second step x star, consider that the first, second, third, fourth reading which you do k number of times, and it is x star 1, x star 2, this 1, 2, 3, 4 are the picking numbers. So, each set which you pick up is x star, x star, x star, and they are marked as x star 1, x star 2, x star 3 till x star k. Now, calculate the estimate of the parameter say theta that we will like to obtain and call these estimates as this. So, that means theta star hat star 1 is the characteristics of that actual small sample of size n which you have picked up the first time, that one basically denotes it. Then if when you pick up the second time, it becomes theta star 2. So, these hats which basically means they are the estimated value corresponding to the first sample which you are drawing, second sample you are drawing, third sample you are drawing, so on and so forth. So, you such find out, say for example, such groups of k in number, each group basically having small n in number of observations. Now, these estimates from the bootstrap basically estimate the distribution parameter which is basically theta hat, calculate the statistics and the distribution for the bootstrap estimates which is corresponding to the distribution of theta of the parameter which you want to find out. So, the averages, so called averages or estimates which you find out from each subsample n and you repeat it k number of times, then the averages of this average depending on some characteristics would basically give you the actual parameters values in the long run. So, let us understand that with this slide. The slide may be a little bit cluttered, but if you look carefully when you are reading or when you are listening to the notes, obviously the slides would also be there by the side, and I am sure when you are in for all the other lectures till now which you have studied, obviously as you listen to my lectures you also refer to the notes on the slides. Now, as you are listening to whatever I am saying, try concentrating on the slide also. Now, if you see the leftmost set of column which is there, it basically gives you the limited number of observations and there are 300 in number. So, this consider that 300 is the maximum such sample which I can ever pick up from of the population. Consider that I am doing some destructive testing. I am giving us a simple example, or you are doing some marketing survey, or you are doing some HR related issue survey, or you are doing some geographical survey, you are trying to find out some concept of how frequently earthquake happen, or say for example, what is the rainfall which is happening, whatever is. Consider that you do not have actual observations and you have the observations, actual observations you do not have the whole list, you have only have with you 300 number of observations, they are marked as x1 to x300. Now, what you do is that you stack this x300 in a column format. So, the first, and consider that you are doing it in an Excel sheet, the A column. So, let x1 to x300 be placed from cell 1 to cell 300, and then you basically pick up that block and copy paste it repeatedly, say for example, k number of times, k can be 200, 300, whatever, that is immaterial. Now, what you do is that once you have that, if you look at that column, it is basically 300 is being repeated in blocks. Now, if I ask you to pick up set of observations, what will you do? You will basically pick up observations, like if I tell you to do it 30 number of times, so you will pick up the first 30, then 31st to 60 and repeat it. Now, once it's there, if 300 are there, So, 300 if you pick up 30, so within 10 such pickings it will be exhausted the first block. Then again if you go for the 11th block, again 11th block would basically be repeated by the first one. Then a 12th block will be repeated by the second one, which means the averages would come out to be same, which you do not want it to be. So, what you will do is that the blocks which you have, you jumble, shuffle them totally. So, if you shuffle them totally, how would it look like? Let us pay attention to the second and the third column. The second column which you have is all those 300 which have been repeated. So, this is the first block which you have, the second block, the third block, so on and so forth. So, you have they are in blocked. Now, you shuffle all the observations I noted down. Is basically they are kept in a box and you shuffle it rigorously and then basically lay it down in the column. So, if you lay down in the column, then randomly, this is just snapshot of random, x40 observation is there, then the x198 is there, 674 is there, 58 is there, so on and so forth. Now, if you note down, if you now pick up a small block of say for example 30 observations and you find out the mean, nowhere in the case of if you pick up 30 observation, then the 61st to the 31st to the 60, 61st to the 90, if you keep repeating it, they would not be in instance where there may be cases by 0 probability be rest ratio, they would not be in instances where there would be repetition. So, now what you have been able to do is that you have been able to jumble up in such a way that such repetition would not occur. And if that does not occur, then your first major task is already over, trying to basically characterize from the sample some characteristics of the population such that you can proceed and try to find out the average characteristics in a very nice manner. So, now I will take a pause, end this class, and the next class I will basically repeat it in much more greater details with an example which will make things much clearer to you. Thank you.